We're starting when the room is full. Okay. Uh, Thank you, everybody, for coming here, joining my talk. Uh, Today, I want to talk about the status of JAX-RS, what we have reached so far, uh, and I want to show you particularly code you can write with the next release that we will do very, very soon. About the project, JAX-RS is a community-driven project, so all decisions are democratic. If you want to join, go on GitHub, JAX-RS API. We are happy for every helping hand that chimes in and helps our team. There are two people in particular driving progress at the moment, which is me and Christian, but we are not doing that full time. We are only volunteers, so we are really happy if other companies can bring more committers to the project. What I'm talking today about is the transition from JAX-RS in the application server world to JAX-RS in the microservice world. JAX-RS had a long time behind its invention. I think the first release was 2007, which is 12 years ago. And back then, we had application servers as the standard technology. And an application server has a problem. It's a full stack where you run on top. And when your hardware is exhausted, you need exactly the same stack again. So you do a vertical scaling, and it's not dynamic. If you want to do that dynamic, you have to fiddle with virtual machines booting up and all that. It's not really agile. And you have a lot of stuff in that application server that were necessary years back, but were possibly not needed by your application at all. So you scale a lot of stuff you actually don't need. JAX-RS was made for exactly this up to, let's say, 2.1. Then we had the transition to the Eclipse Foundation, and it was clear to all the committees that this is not the world we're living in anymore. The world today looks different. We're in the cloud computing era, and if we want to do scaling in the cloud era, then we actually do not copy the complete application server instance, but we have lightweight containers which we can create on the fly within milliseconds. So to support such agile scaling, we need different technology, and we need changes within JAX-RS itself. So what can we do? There's one thing you can do. You can go, for example, use Project Helidon or Project Quarkus, which are providing JAX-RS in an agile fashion to you, which will be very well working in the cloud-native era. This is not what I'm talking about today. These are great products. I'm sure there are lots of customers which are happy with that. What I want to talk about is what can you do without using another product. So what can you do with native Java, with native JAX-RS? One application we had was bringing JAX-RS to very small servers. So this is one server we're using in our company, and this shall run an application which is basing on JAX-RS. And you can see the metrics. It has only 256 megabytes RAM. It has a low LAN. It's very small. It had one single core at 1 gigahertz. We tried to start Glassfish or Payara on that device. It does not boot. So we had to find a solution. The effects we have with cloud computing on JAX-RS is it must be faster, it must be less resource computing consuming, and it shall not provide that boilerplate of the application server. It should be lightweight. So for that, we do several changes. For example, we get rid of non-used modules, non-used by 80% of the today programmers. Like getting rid of JAX-B, which is a dependency. We have to rename the package, which is not something we wanted to do, but we needed to do due to trademark restrictions. And we like to get more up to date with other APIs like CDI. So we are driving against getting rid of add context, getting into add inject. This is just a roadmap what we try to do, which is not directly related with microservices, but just so you know what is coming in the next month. So JAX-RS 2.2, what's in the box? The box will be delivered within the next weeks. So this is good news. So all code examples you see today will be working like that when you download it in a few weeks. And inside that box is the new Java SE Bootstrap API, which is not a completely new invention. This is some technology that was in the products, you know, like Jersey or CXF already, but it was not accessible without using the native API of that product. So what we did was create an API around that products, so you can switch the products under the hood. I will demonstrate that within a few minutes. So you're not tightly bound to, for example, Jersey. So this is the roadmap. I skipped that because we only have 30 minutes and I want to do code. So if you try to use the examples today, you need a lot of snapshot versions. Don't do it. Just wait a few weeks, download the final versions, and you're much better done with that. So this is the slide for the end. Let's get into the code. So what I want to show you is a very, very sophisticated application, which does a wonderful thing. Where is it? Sorry. I need my resource. I hope you're already known to JAX-RS, so you understand the code I show you. If not, just ask questions. I open the sole resource. So this is the whole application. The application is so great, it knows the ultimate answer for all questions. And the answer is obviously 42. So if I do a GET request on question/ultimate, what I want to get back is 42. We know all that. If you know JAX-RS, we know that. So in the real world, applications are not so easy like this one. They come with interceptors, they come with filters and all that. There are different types of things you can do in JAX-RS outside of the original resource. And when it comes to tracing bugs, you have a problem. You have to start up an application server, you have to deploy the application, you have to remote debug on the server, or you have to add some system out print line or logging in your application, so you understand what is going on when a request comes in or when a response is sent back. We did that for a few months, and it's not nice. Remote debugging, hell. Okay, so what is great about the changes we do is, with our JAX-RS Java SE Bootstrap API, we can debug within the same process. So there is no application server. There is only a few pieces of Java that we need. And this is the major change that JAX-RS 2.2 will bring. So you still can certainly do application servers. This still will work, but you don't have to. In the past, you had to. So how do I get this great application running? I hope you can, okay, it's big enough. You have to write some bootstrap layer. This is what the application server typically did for you. He booted a lot of services, 99% you never needed. And he eated up a lot of resources. And we needed that resources. So with this code, this will not happen. With this code, we will get a running JAX-RS service with an HTTP address. It will work just with an application server, but there is no application server. And due to that simplicity, you can debug inside your IDE without remote debugging, without tracing and all that. And I'll just do that so you can see what I mean. So it's booted. If you ever started Glassfish or Payara, we would still be waiting now. It's done. It's in the debugger. It has booted. It serves the application. So what is the Bootstrap code actually doing? I want to give it an IP port. So I have this line where I parse the system environment. Let's skip that code. This is the interesting one. I manually create an instance of the application interface. You know this interface? This was more or less good for nothing. You gave it just a list of the resources you want. If you didn't do, it did auto-scanning. With Java SE, we want to create this instance manually because then we can debug into it. I skip the debugging here, just go to the next line. Next step is, your application server had some kind of configuration. Like Payara had a nice UI where you gave properties. This is not there, so we have to build the configuration by hand. This API allows you, using a nice builder API, to build the configuration your server is using by plain Java. So we have here a configuration builder. We provide the protocol it shall run. And we say, please listen to all ports of our local host. All IP addresses of the local host. And please use the port we specify here. So this is the most essential information you need, just to have an URL you can listen to. And when you have created this, then we can go to the next line. It's a little bit small. So here comes the interesting thing. It says JAX-RS.start. So what this command does is, it asks the implementing party, which is, for example, Jersey, CXF, or something like that, RESTEC, to use this application instance and to serve it on that IP address and port we have in the other hand in the configuration. And it tells even more. It's a completable future. It gives us a trigger when it's done. So we know for sure this application is able to serve at this address now. So the next breakpoint I want to have is here inside. Go on. So it's a little bit small screen. We have the log of the application in the background. It says it automatically chooses to serve on port 51526. That's a feature we don't have with application servers for good reason. But on my local debugging environment, I am not sure which ports are used, which ports are free in the moment, and I don't want to skeek it by hand. So I can give it in the configuration the value 0, and with the value 0, the underlying party, which is Jersey here, seeks a free port and starts on that. And the question is, how in God's name can I know that port without looking in the log file? So what we get in the next step is, okay, we skipped it, sorry. In the next step, we get an instance of the running application, which is something different of the instance of the application I created. So what I have here in the hands is not only that piece of code which I wrote to implement my application. Here, this is wrapped by information like what is my actual chosen port. And with that instance in my hand, I can do different things. For example, I can ask it what the underlying party decided. For example, where is it? Oh yeah, it's a few lines later. I can ask it for the actual configuration Jersey has chosen to use. I gave it the IP port 0, and it has chosen 51526. And this configuration can be used to inspect what Jersey actually did. And there are nice other things like I can call the stop command. So I have an instance handle in my hand. This is my running application. And I can use this handle to stop the application at once, like shutting down. So in the past, you had to manually shut down your application server. Here, you can trigger that your instance shuts down, and the shutdown is within milliseconds. So it's not really complex. It just looks complex because it's new to you and the lines are so small. Okay, and what I'm doing here is I give you an output of the port. So now the application server is running. I do that again without a debugging to see how fast it is. Okay, the long waiting time was Eclipse. Actually, it needed about a second to start the whole application. It's serving now. That's it. So what you can do with that, I told you can debug in the application when a request is coming. And this is the nice part. Just need to start again debug mode. Debug. Yes, skip the breakpoints. The debugger is a bit slow in Eclipse. This has nothing to do actually with the application. And here in the bottom, you can see what I'm doing on my terminal. I just invoke a GET request on that port. I just need to correct that port. Okay. So you noticed when I pressed enter, it started a request in the bottom panel, and in the top panel, the debugger stopped the application because I had a breakpoint in my interceptor. And this is what I told you 5 minutes ago. If you are troubleshooting your application, you just do breakpoints wherever you want without remote debugging. This is all one local machine. This is all one single process. You can do everything your IDE can do. You can do everything Java can do. This is actually plain Java. There is no magic behind. There is no special technology. You don't need plugins. You don't need anything. Just use your debugger. And this helps a lot in troubleshooting your microservices before you get them into the actual deployment environment. So you can inspect here whatever you want, like the context and something. You can replace the entity, you know all that, what you can do here. Just go on. And here is the answer. So actually, what is the great thing about JAX-RS 2.2? For me, this is the best feature we added to JAX-RS 2.2 because my turnaround times is much improved. I don't need to build a deployment bundle like a WAR file and write some descriptor XMLs and deploy that to an application server and boot it up and attach the remote debugger. I don't need all that. I just stay here and write pochos and debug my pochos. And they are real HTTP servers. There are no fakes. This is no mock-up. This is the actual code that will later run in your deployment environment. And this is a very nice thing because we can not only debug in our code, we can debug in the underlying layer. So if there's a bug in Jersey, for example, if there's a bug in Eclipse Link or whatever library you have used, just debug into it. It's pure Java. Another nice thing you get, and you will have noticed that before, is the boot up time, which is very much increased, and certainly that has a reason. The reason is we don't load a lot of classes. Class loading is very slow in Java. We only need that classes that we actually need. In fact, if I build a jar bundle from this application, it will come with a few more classes than you actually need. Typically, if you bundle Jersey with your application, you get around 50,000 classes. You don't need them. There are plugins for whatever. You don't need them, but they're still here. So what we did is we use Maven Shade plugin to get rid of that. The Maven Shade plugin inspects your application and removes all the classes you actually will never touch. So this is a step we did in Maven. So let's see what Maven gives you to write microservices. Let's make it bigger. Don't get scared by the XML. No, bigger. Why isn't it getting bigger? Okay. Don't be scared. It's really easy. What we do is we say we want to use Jersey. You need just some implementation. It's not necessarily Jersey. It can be CXF or RESTEC or whatever. We need JAX-RS API, so our compiler needs what we talk about. This example here explicitly loads JAX-B because I wanted to use it. This is not a must. You're free to do that. You can skip that. This is also JAX-B runtime. This is the nice part. We can replace the modules Jersey provide. Here we say we want the Jersey server, which is the one implementing that Bootstrap code you have seen. We can replace the injection framework. We use HK2. In future, we can use CDI. We're working on that. And here we say we want explicitly Grizzly to serve this application. Sorry. We want also support for JSON binding, which you are free to use. You can skip that too. This is also media binding. And that's it. And what we do is simply compile that, make a jar, and this is the shade plugin I mentioned, which is configured to strip barely everything. So the jar that it's produced is really small. Sorry, this is the wrong one. I need to open another console and you can see how small that thing is. So let's compile it. Come on. So this is the shade plugin, which tries to pull everything it needs and then strip the things not needed. And now let's see the result. The result is this. So my Hello World application plus everything it needs to be a full JAX-RS application running on HTTP, using that port and so on, just has this size. So if you download an application server, it's a lot more. It's the nth of that. And that nth has to work and it has bugs. And it's slow and it eats resources. So this is all you need. You could start that. Please work. Yeah, that's it. We just started an application server. I don't know if you have a stopwatch. I think it was a second. Okay, so I told you the nice thing is this is not bound to a native implementation. It uses a native implementation, obviously, like Jersey, but it's not bound to. Let's change something. Let's replace Grizzly. People don't love Grizzly, it's a bit slow. Let's use, for example, Netty. Now what happens? Here should pop up Netty somewhere. There it is. And now I just start the application again. Sorry, I need a console. Yeah, there it is. I have not changed the application. It's the same Java code. It's the same JAX-RS. I just told the build system, if you build that jar, don't pull in Grizzly, pull in Netty. We can do that with Netty, Chatty, JDK a lot. We could even replace completely Jersey by CXF, but I have not the right coordinates here to try that. I tried it earlier, it works. So this is one hand. Now the other hand is inside of Docker. Today we want to Dockerize everything, so we want our microservice to be a Docker container. If we pull the Docker container, for example, Payara. Payara has a size of 807 megabytes. This is what you need just to have the ability to serve HTTP. I don't want 807 megabytes for that. So what we want is this one, which I compiled 42 minutes ago. It only has 240 megabytes. And this is not only the boilerplate application server. This is my complete application with everything it needs. So certainly the build is rather fast, and it boots very fast, and it needs very, very low resources. So the boot, let's see. I think, yeah, I have it here. Let's build that container again. I don't have it here. What? Okay. Why is it not finding Docker? Okay. Just go in the directory again. So, yeah. Okay. This is a trick. I did it 42 minutes ago with everything cached. Originally, that code needed about 10 or 20 seconds to build a container. The interesting point you see is the line where it actually runs Java. So why do I run Java when creating the Docker container? Because we want to gain load speed. And for that, I'm using app-CDS. So what does app-CDS do? App-CDS loads everything from the jar file in the JVM, checks that all that class files are valid, tries to compile it, and makes it runnable. But I don't need a container which is in that state. I must stop it so I can give it to you. So I stop the container then and pull the cache file where that preloaded applications are stored by app-CDS. So this line effectively is just good for preload. Later, when I start the container, the Java classes. This produces a benefit of several seconds independent of your application size, because the JDK is rather huge. Because I wrote a few code lines Java, but under the hood it loaded several thousand. So this preloading is done here in that line. To reach that, you need a small change in your Bootstrap code, which is this, larger. This is simply there to stop again when app-CDS is done with loading. So this is what we do as a trick for Docker. So this line, okay, so that's it mostly. All the command line flags have to do with Java 9 and app-CDS. It has nothing to do with this talk, actually. I just need that to make it run on this machine. So now we want to actually run it. I know time is running out. Docker, I had Docker run here. So we run Docker with this container image. I have to give the right one, CO6CDD. We map the port with the -p, and we provide an environment variable. So this variable is good for giving it a static IP port. If you don't do that, it will use a free port. And you don't know this from outside. So in this deployment scenario, we don't want to have automatic port scan. We want to force port 8080. So that's why we inject this variable. The port is already allocated. Oh, great. Okay, but as time runs out, you see this was the load speed for the container. We could try to stop that other container and try it again. Yeah. Okay. Okay, there it is. That's it. About 1 or 2 seconds. I have not measured it yet. This is the complete Bootstrap with app CDS, with the shrink down jar file, with your application in it, with Jersey in it, with all the dependencies Jersey has, but reduced to the classes you need. And this is all you need to start building a microservices pure Java. Again, there are no tricks. In case you just need small applications, this is all you need. There might be cases where you need Helidon. There might be cases where you need Quarkus. There might be cases where you still need application servers. But if you don't need it, with JAX-RS 2.2, you now have the freedom to do pure Java, debug it in your IDE, and start it within a second. Just one last slide. I measured on a real small hardware device, which is very, very limited. It's much smaller than this laptop. And the actual time it needed to boot was 2.5 seconds. When using Payara with microprofile, it needed about 10 seconds. And if I tried to start the full-blown Payara application server, I gave up after 60 seconds because I ran out of resources. The jar size of the complete application is just about 6 megabytes. So this is the boilerplate you have to live with. Microprofile is 70 megabytes, and the Java EE server is 142 megabytes. So we are very near the target that we have, that running a JAX-RS application is about the size running a pure Java application. And this is what we try to reach with JAX-RS 2.2. Okay, if there are questions, then I'm through with all slides. Please don't hesitate and ask. Okay, thank you, and have a good time in Ludwigsburg.